people that is still sleeping, I guess.
Don't forget to record, Mr. Charif.
Yep, record. Here we go. Thank you for reminding me. Okay, so we talked about STP. What's an STP? It's a dizzy tree, huh? Spanning tree protocol?
Spanning
Yeah, we call
tree
it spanning.
protocol.
Okay, what's the main purpose for that?
Redundancy.
To build redundancy and to eliminate what? Loop
Loops.
at layer 2. So, um, let's do some exercise to prevent now. One thing you need to be aware of, as you know, and we talked about that on VLAN. VLAN 1 is the default VLAN. So all the ports belongs to VLAN 1. We know that facts. And also, what else we know about VLAN 1? It is what? It is the native VLAN. So people trying to change from default to something else. So for example, if I want to make native VLAN 99, so if you do that, you need to make sure you do it on all the switches because when you connect two switches, you connect it with the trunk port. And as you can see, the trunk port here command like switch trunk native VLAN 99. If I put it on the switch over here, like SW1, for example, native VLAN 99, and the other switch, which is switch 2, connected to the switch 1, and I put native VLAN 1, is going to have a mismatch. You're going to have a problem. So you need to make sure all the native VLANs has the same ID. So if you want to stick with 99, you make it all 99. Question at this point. I think I can use a packet tracer. I think I have one already started on it. Let me see if I can bring it up. Well, packet tracer. Yep, right here. Okay, so that's the packet tracer. So to prevent and to implement STP, okay, we need to create what? We need to elect what? Remember from last time? Did we talk about that, or we need to create some reference point? What's the reference point? Here we go. Like for example, I have 4 switches. They're all connected to each other, and they all supposed to be trunk ports. Now, to prevent a loop, we need to block somewhere. Okay. Now, physically, they all stay connected, but logically, we need to disconnect one end because I don't want that frame to go into a circle. Okay. So that's why we connected. We might disconnect here, 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 or here. Who's going to determine where we need to disconnect? That's the main question. Do you remember from Friday what we talked about? So what determine is we need to have some kind of reference point. That reference point we call it what? The root bridge. The root bridge is going to give me the reference point. So how a switch can be a root bridge? Anybody knows?
The lowest MAC address. By
The switch
default.
has the lowest BID. Remember the BID? The bridge ID? So that's why I put all the MAC addresses for each switch right here. So the BID consists of two things. It consists of the priority value, which is all the switches by default has priority value 32768, and the MAC address. That's what makes the BID, the bridge ID. So since these switches are by default is going to have the same priority value, 32768. Now, who's going to break the tie? Because they all have the same priority value. What break the tie is going to be the MAC address, the lowest MAC address. So which one of these has the lowest MAC address? Well, let's
Top
see.
right.
I have 0005, I have 004, I have 001, I have 00A. So this one is the lowest MAC address. Therefore, SW1, which is SW1, switch number 1, or switch number 2, I'm sorry. So this SW2, it becomes a root bridge. It becomes a reference, okay, reference point. So what does that mean? Once I have a reference point, now any switch is connected directly to the root, which is here, the root bridge, which is the SW2. It'll become, this one is connected to this one, it will become a root port. This is what we call root port. Okay, because why this is the root port? Because it's connected to the root bridge. Now, all other ports, this is also root ports. Now, all other port is going to be designated port. So, for example, this is going to be designated. This is going to be designated. Now, over here, we need to know this is going to be what? Because we're going to have designated port per segment. So, designated. This is going to be blocked. Okay. And this is going to be
Designated.
root port. Now, if you look at this one here, is really this one is confusion. Has some kind of confusion here. Now, if I'm on this switch, all the path to the root bridge are equal. So I can go this way and this way because this is a gigabit. And from the table we saw last time, the gigabit is how much the cost? It's 4, I believe. What? How much?
4.
4. That's right. So 4. So I have 4 plus 4 is 8. If I'm here, 4 plus 4 is 8. So why we don't go this way, we go that way?
Because that other port's blocked.
Yeah, why is blocked? That's the question. Why I don't block it over here, we'll block it over here. Because it's equal cost. You follow?
Right.
So
Gotcha.
the reason is because I'm going to compare the MAC address here versus the MAC address here. Which one is lower, SW3 MAC address or SW1 MAC address? This is 0004. This is 0040. So which one? So this
The
is
top
lower,
left.
therefore we go in this way. You follow?
Hmm?
Now, let me ask you a question. What happened if I connect SW4 with SW2 right here? Is this going to change? If I go from here, let's say we go with the fast Ethernet 0/24 to this guy here. Okay? So what's going to happen now? Are we going to have the same outcome? Or something's going
No.
to change? No? Why not?
You're not gonna have the same outcome. The port that's blocked on the gigabit 02 on switch 4 will now become an active port, whereas the fast Ethernet 24 on switch 4 will now become the block port.
Okay, so this is
Nope.
this is a different result. You see, this is a blocked right here. So I'm going to have the same. I'm not going to use this one here. We still have the same result. And the reason why we still have the same result, because what's the cost for here?
8,
19, because this is
9.
fast Ethernet. So still is, even though it's directly connected to this one here, still it's cheaper to go that way. Because the cost 4 and 4 is 8, while this one still
Gotcha.
cost me 19, which is still larger than 8. Therefore, it's not going to change anything in the outcome, even if I connect it directly. Now, if I have a gigabit connection between the two, then the answer will going to be changed. You follow?
Okay.
Because this fast
Yes, sir.
Ethernet is not going to make any difference. You get the idea?
So it only slows down. So my question is since you added that fast Ethernet connection, the administrative cost is more. Why wouldn't that one be blocked off instead of the other one, the gigabit?
Okay, this is fast Ethernet. Okay, this is not going to change the formula that this switch here is going to be the root bridge, right?
Correct.
Okay. So now I need to make a choice and then make decision on this SW2. Okay. Now, any switch is directly connected to the root bridge is going to be what? A root port.
Correct.
Why we call it root port? Because this is the fastest path to the root bridge. Now the question is this link is the fastest path to the root bridge? The answer is no. Why?
No.
Because it's connected
Speed.
with fast Ethernet. The cost here is 19. Okay? Because it's fast Ethernet. Okay? So the cost over here is 4. This is 4. This is 4. This is 4. And this is 4. So it has to accumulate it. So it's still cheaper to go this way than going straight this way. You follow? Because
Gotcha.
the cost over here
Yes,
is
sir.
19. So really it doesn't make any differences if I put this one here or remove it. Now, Now, if I replace this link, the gigabit, by fast Ethernet, then the outcome is going to change. You follow?
Gotcha.
Since
Yes,
this
sir.
is a gigabit, this is gigabit, this is gigabit, and this is gigabit, the outcome is not going to change. But if I change any of these link right here, this one or this one to fast Ethernet, then it's going to be different. All righty. I wouldn't need this one. Let's see what else they say. So this is like a configuration. We already talked about the VLAN 10, 20, 30, 99. Once you configure, for example, interface FA0/1, and it's connected to, this is a trunk port, okay? And you go switch mode trunk, which is good. And you put switch port trunk native VLAN 99. The minute you put native VLAN 99, you're going to have an error, okay?
Mm-hmm.
Why are you going to have an error? Because if this is native VLAN 99 on this switch here, and the native VLAN still VLAN 1 on this switch, they're going to give you
Error.
native VLAN mismatch. So to
Yep.
correct the situation, you need to go back to S2 and do this statement here. You go to F0/1 in here, and you say switch port mode trunk, switch trunk native VLAN 99, blah, 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 blah. Then we'll fix it, okay? I think we talked about this one before, switch port trunk. If you want to change it, you say no, switch trunk native VLAN 99. So if you want to go back to the VLAN 1, you can do that. What else? Switch port mode access. Yeah, this is to reset the trunk to default. So, okay, so basically this is all lab. We can do that.
DTP.
DTP dynamic trunking protocol is for Cisco. We use Cisco for that. Switch mode trunk, switch port negotiate, switch mode dynamic auto. This is between desirable and auto. We talked about that. So for that trunk, for the port to be trunk, if you set both sides on auto, is not going to be trunk. If you put this auto and this auto, is not going to be trunk. So this has to be auto, this has to be desirable, or both has to be desirable to establish trunk. That's what we're talking about. I think we have a slide. Yeah. Permanent access mode to negotiate to convert neighboring link into an access link. If the dynamic auto will become a trunk interface if the neighboring interface is set to trunk or desirable mode. So if you have one switch like S2 set on dynamic auto and also S1 set on dynamic auto, there will be no trunk. So, but if you go to S2, put dynamic auto, and S1 is set to trunk or desirable, then this would become a trunk.
It'll trunk.
Yep. Same thing. Dynamic desirable actively seeks to become a trunk by negotiating with other auto or desirable interface. So if you have auto on one side, desirable on the other side, then you can have a trunk. So if you have a trunk on both sides, you can have a trunk. And that's the, I think we talked about this one, the slide that give you that one. Okay, DTP, what else? So what we're gonna do, I'm gonna give you an exercise on, this is all lab, what we learn on stuff. Okay. So, for example, suppose I want to change. I want to make S1 as a root bridge, because this is an old switch, this is a new switch. Let's see. First of all, so some kind of review what we did before. If I go to this switch here, well, let's discuss that something first. You do enable, and you would say show spanning tree. Okay, you're going to see the spanning tree. Show spanning tree. What you see? You see, it's a root bridge. They tell me the root. Okay, first of all, you need to start with VLAN because the root bridge based on VLAN. So VLAN 001, the root ID has a priority 32769. Now the default is 32768. Why we have 69? Because we added the VLAN ID to it. The VLAN ID is VLAN 1. That's why we added the 1. It became 32769. And also the root ID has this MAC address. So this MAC address match who? Match this switch right here. Switch number 2 right here. You follow?
Mm-hmm.
So, and have no cost, and that's basically your root bridge. Now let's go to the second line, interface, gigabit 0/2 and gigabit 0/1. And as you can see, the role is designated, and basically can forward information. Forward. You follow? And also they have what? Point to point, means it's going from one switch to the other. That's what we call point to point. Now, one thing I need to know is the spanning tree mode. This is spanning tree enabled protocol IEEE. So this is like a default. So I can change that to something else. So if I go, for example, config T, and put spanning tree, put question mark, I have a 3 mode over here. One of them is mode, and they put question mark. It's supposed to have 2 other mode. So I can put it on a PFST. What's a PFST? You remember that? Pair VLAN.
Fast.
Pair VLAN. So basically we say pair VLAN. Did we talk about that?
No, sir.
Did we talk about the different types of VLAN? STP. Are you sure? Oh, it's my fault. Why don't we talk about this? It's the wrong slide. Nobody pay attention to that. I know. We're on chapter what? I put the chapter 3. We're on chapter what? We're on chapter 5?
3?
No, you took tests on 1, 2, and 3, and 4. So you're supposed to be on module 5. Right?
Got us in I think you got us in the next class.
Hey, man. Okay, so that's what we're talking about. We talked about. I was wondering why we talk about all this stuff. Okay, so we already learned all this stuff here. Operations. That's what we talked about. The loop free. That's what we talked about. The root bridge. How you elect it. We talked about last week. The one with the lowest MAC address and the lowest priority becomes the reference point or the root bridge. So in this case, we have the MAC address 00A, 003. This is 00A, 002. And this has the lowest MAC address, but it doesn't have the
The higher
lowest priority. This has the highest MAC address, but has the lowest priority. Therefore, this guy is going to win to be the king. This guy is going to be the root bridge. So that's my reference point right here, root bridge. So all the connection, all the switches that's connected to this guy here is going to be what? The root port based on cost. So this port right here is going to be a root port, and this is going to be root port. On all other connection is going to be designated port. So this one is going to be designated. This is designated, and this one over here is going to be designated all alternative. Okay, so we have designated per segment. Now we're going to block it somewhere to prevent the loop. So based on the cost, the MAC address over here is less than the MAC address over here, but they have the same priority. So we break the tie by the MAC address. Therefore, we're going to block it right here. And this is going to be another designated port. You follow? So,
yes, sir.
This is alternative. Now, basically, we're going to block it right here. And the reason why we block it over here, we're blocking it logically, not physically. Okay? And we're going to go over that exercise I'm showing you. But that's the stuff we talked about last week. You notice that we have 32,768 plus 1. That's why we have 69. Why? Because we're dealing with VLAN 1. Okay? We don't have any other VLAN. So the native is VLAN 1, and it's the only VLAN we have. And that's how you elect the root bridge. So the cost is 19 because why 19? Because this is 19, this is 19, this is 19. Because we have fast Ethernet. Now, if I have this is a gigabit and this is a gigabit, guess what?
The port between
is going to be the root bridge, the root port. You understand what I'm saying?
Yes, sir.
If this is gigabit and this is gigabit and still this is fast Ethernet, I'm not going to have the same outcome as you see over here. Okay? Actually, let me show you what I'm talking about. That's simulated right here. First of all, I don't know at this point who's going to be the root bridge. It's very hard to tell unless if I know the MAC address, right? So I go connect this guy here. Let's connect him with Ethernet first to see. Okay. Now, let's advance it a little bit. Okay, so what it tells you, who's going to be the root? Who's the root bridge in this picture? Let's say this is S3. This is S1. This is S2. 2, and this is S3.
S1.
S1. Okay, so this is going to be root port, and this is going to be root port. And what else you can tell? What's the difference between S3 and S2? Which one has the lowest MAC address? S2.
The lowest MAC address would be S2.
S2, not S3. Well, without looking at it, it's just because it's blocked right here, it's open right here. You follow? So now, if I say this is the root port over here, if I change the link here to gigabit and here to gigabit, now we're going to have a different outcome. See? I mean, still, this is going to be the root bridge, but the root port is going to be different. Let's see. So I'm going to keep this one as fast Ethernet. I'm going to change these. So I'm going to go gigabit. And also we go gigabit right here. Okay. You see that? Now it's blocked over here. You see? Now things have changed. So now I think S2 is a root bridge. Let's check it out. So how you know? We can, let's see, let's go to each switch and copy the MAC address so we know exactly what we're talking about. So this is the MAC address for the switch. If you do right here, you right click on it, you copy it. And you do this one, Control V. What is the interface? Oh, yeah. Control V. You go to this S3. And we need to go over here. Copy and need to go paste it right here. Okay. So who has the lowest MAC address? That's one. That's 000A. This is 006. How come this is getting elected? I guess because they have fastest port. Let's see. We go over here and we're gonna say
Spanning tree.
enable. This is show spanning tree. Okay, so this is tell me the guy with this MAC address is the root bridge.
Yep.
Which is EVC. See that? So actually still S1 the root bridge. And the root port is going from, this has become root port right here. And this one, it goes to designated, and this is going to be a root port right here. Because really still the S1 as S0, I mean 000A. So whoever have this MAC address is the root bridge. Now I am in this switch here. Notice over here it has a cost. If really S2 is the root bridge, there will be no cost because it's what's telling me over here. What's telling me is to reach the root bridge is going to cost you 4, which is this link here because it's a gigabit. You follow? So if you look at here on the interface, you see designated, which is F02. F02, that's the designated port. And G0/1, that's a forward port. Remember, the switches goes into 5 different modes. You have a blocking, you have learning, forwarding, listening, and disable. Okay, so those 5 modes for this the ports. And the same thing in here. If you go click on this guy, you will see no cost. Okay. So we go right here to enable config T. And what we're gonna do right here? No, we're not doing config T. We're gonna show spanning tree. Okay. So what you see over here, root ID 32769, which is the same as the other one. And the root bridge has whoever have this MAC address, which is S1. Notice over here, what's the difference between when we say spanning tree protocol on this switch and this one here? On this switch here, no cost. You see that? There's no cost involved. In here, we have a cost of 4. So what you expect to be the cost on this switch right here? Anybody want to guess? What's the cost in here to reach the root bridge? No guessing? Deruso, you still there? Show spanning tree. What's the cost? Somebody say something? Chat. 8. You're right. It's going to be 8. Why? Because I have 4 here and 4 here. So you put here. And as we expect, this is the cost, which is 8. Because this is 4 here and 4 here, and still the root bridge is still this guy here with the MAC address. Now, what is this port? This is alternate port is going to be, and this is going to be forward. And that's what you see on the status right here. F0/1 is blocked, basically. And this is forward. And this is the root port. You follow? So, how about now, if I change this link to gigabit, still it's going to be the same thing, but one of these needs to be blocked. So what happened? We're not going to have the same outcome. So I go right here. You go no. And I take this link and go to gigabit 2, gigabit 2 right here. Now I'm going to have a different outcome. So this is blocked, this is open, and this is open. Now, why this is blocked? Because this is 00E, 0, this is 006. Okay, so this is less MAC address. So therefore we'll block it right here. Now this is a root port designated, root port designated, designated, blocked. You follow? Question to you. So how I can make SW1, switch 1, or S2 in our case, as a root bridge? What am I supposed to do? I cannot change the MAC address, right? Because that's printed in the circuit board. What I can do is what? Change what? I can change the priority. So that's what I'm going to show you. If you have some kind of, that's what I'm going to show you over here. I want to make one of this switch basically a priority. So before I do that, I would like to update the firmware on this one here. I mean, I don't have to. I don't have to update the firmware. But I want to make this one as root bridge. I mean, yeah. So if I go over here, I go to, let's do it on this one here, because there's too many routers, too many switches to do it in here. So let's make this one as a root port. First of all, what I need to do, I go over here, put config T, I put spanning tree, protocol. First of all, I put mode, question mark. I need to put a rapid PVST. That's basically what we talk about. They have a different standard. The common standard that started in the 90s, and they improved it on the rapid spanning tree protocol. Then Cisco say, okay, we can open per VLAN. Okay, so then the industry put rapid. So then Cisco said, okay, we're going to do rapid PVST. So I'm going to put rapid PVST. Now I'm going to put spanning tree protocol, question mark, VLAN. I can put VLAN 1. And I can say a priority, or I can say root, okay? So if you put a question mark here, that's the priority. This is where you can set the priority. You can say priority, and the priority has to be multiple of 4096. So I can put 4096 or whatever multiple of 4096. And you put enter. Now, exit. WR. Now, if I put show spanning tree protocol, okay, this is going to change. Spanning tree protocol enable our SDP. See that? Now it's our SDP. Rapid spanning tree. So now this becomes a root bridge. So let's test it. So if we say, I mean, I don't have to test it. As you can see, designated means what? Once you see on the switch designated means what? This is designated means what? Means this is the root bridge. Well, you can see, you can show a spanning tree. And if you expand it here, what you see? The root, the priority is 4097 because we put 4096 because it's VLAN 1, added the VLAN ID to it. And the one has this MAC address, which is 4E64 and no cost. So 4E64 end with 4E64 is this guy here. So therefore, this becomes the root bridge. And you got the idea? So really, you can select and you can dictate which port I mean, which switch you want to be the root bridge. And I can say, I can make this one or this one, doesn't matter. I can make it the backup designated port. Okay. Just in case like these over here. And usually you want to select the, when you have like some kind of a more complex situation. For example, if I replace this switch here by a multi-layer switches, then I can make this one as root bridge instead of these right here. This is basically to understand the concept. Now, one more example I should give you. This one here and this one here. Doesn't matter. It's the same switch. Let me plug this one here to this one. And this one to this one here. Notice how long it takes to change the status from listening to learning. It's going to take a while, almost like 1 second. So Cisco, what they said, okay, if this link here is not connected to a switch and there's no risk on it, I can make this port fast. So we can basically I cancel all this listening and learning and all blah, 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 blah. Because if this is the DHCP server, for example, and they have a lot of clients connected to it, you don't want to let the client wait and wait for 30 seconds to get an IP address. So how you do that? You go, for example, on the switch, and you do enable config T. You go config T, and you do a spanning tree. And first of all, let's see if they have the same mode. We can put mode rapid. And what you do also, you need to put spanning tree. Okay, you see that little command here? Port fast. Question mark. Enable. Port FA0/1. No. I think I have to go to the interface. Let me see. Spanning tree enable port fast PDU guard, and this way default enabled. Yeah, enable. So that's what you need to do. Enable. Okay. Be like this. Enable port fast by default in all access. Okay, so I think you need to go to I forgot how to do that. This is it. Interface, I guess. Interface FA0/. Yep. Spanning tree. Questions. Port fast. Port fast. Port fast. Yep. Okay. And you have to do span tree. Okay, so we enabled basic report fast, so it doesn't have to go through this. So if we test it, if you go to this link, to this interface, which is, let's see, F0/1, and we shut it down, and we shut it back up. When we did it up, it goes green right away. If you do the same thing on this guy here, which is F02, and disable it and put it back, you see this is going to take forever because this one is not enabled fast port on it. You see the difference between the two? The one we did? This has a port fast enabled, this it doesn't. Still trying to learn, to listen, to learn, and to get to the forwarding mode. It takes about 60 seconds. See that? Now it's on. So this is one of the commands they can use. Basically, you do that only on the ports that's connected to not to switches. Okay, it's connected to a server basically. Okay, let's see what else we can do right here. What other choices we have? Spinning tree. Spinning tree. Okay, so it's another one. They call it PBD. Okay, this one is a PPDU guard. Because remember we talked about the way those guys elect the root bridge, they exchange, they send the BPDUs among each others. So they always has a message. Are you there? Are you there? Are you there? They exchange information every 2 seconds. So if this port is not connected to any switch, why you want to send message this way? So what that mean? This spanning tree PDU guard basically tell us, okay, don't send the information this way because this is not connected to a switch. So all what you do at this point, you enable it. So you put enable, okay? So by doing so, you prevent any PVDU on this particular port. And the reason for that, for example, if somebody comes in and unplug this one in and put a switch, so that switch is not going to participate in the PVDU traffic. So that's the main reason for this one is like a protection, basically. You're protected. So any question at this point? Are you guys still there or you?
No questions at this point, sir.
Yeah.
All right.
I'm good.
You understand the port fast and the PVDU guard?
To a degree, but I'm still going to have to go back and read over it.
Yeah, I mean, 3 concepts you need to understand. First, it's not acceptable to leave all the switches by default. So if you want to do implement spanning tree or you want to create redundancy, you need to have some kind of plan in mind which switch needs to be the root bridge. And if you have that plan, the question is how to configure it to be a root bridge. What you need to do. It's like one command. What are you supposed to do?
BDPU guard.
No, you have to do the root priority. You have to go to the switch, like I want to make this switch as a root bridge. So I go spanning tree, and I put the root priority to be less than the default, because the default is 32,768. So this one here, we'll put it 496. So you reduce the priority. So once you go to the switch, you reduce the priority, you make that particular switch to be a root bridge. Based on that, you can start, so you'll have an idea. Okay? Now, the question is, if I have a multiple VLANs, okay, so I can, if I have a multiple VLANs, I can create a root bridge for each different VLAN. So we always block the port for a certain VLAN, but we enable it for different VLANs. But now we can do that. I don't think this is on your. Yeah, it was. I didn't see it on your. Yeah, that's the next semester stuff, I believe. Yep.
So basically, we'll be going over this again next semester,
Oh yeah.
pretty much. Okay.
Yep. But I mean, you don't have to wait till the next semester to understand the concept.
Roger.
This is very important, the STP timers and port states. So you go on blocking mode, listening, learning, and forwarding. See that? So that's why the switch, when we disconnect that server right here, when we disconnect this one, and this came up right away. It takes so many seconds, and the reason why, because we enabled this one with what? Port fast. And the reason why you want to do that on the switch, on the ports that is not connected to any switches, to be port fast, especially when you have servers. Because if this is a server, like a DHCP server, like I talked about, or a phone or whatever, you cannot wait 60 seconds. The client, so if you have a lot of clients need an IP address, they cannot wait 60 seconds. That's a lot of time. So able to expedite the process, you go to this switch here, you go to this interface, and you enable a port fast on it.
Port fast.
Okay. Let me do another one, just in case you guys forget the first one.
So, Mr. Charif, we should basically put port fast on something that's not going to change ports, correct?
We put port fast on the ports that's connected to servers or any devices like phones to expect fast service. So that doesn't have to wait till learning and blocking. That doesn't have to go through this process. You see this process here? Listening, learning, forwarding. Because that's what the switch taken too much. 15 seconds, and another 15 seconds. So it's like almost 60 seconds. Like over here, you're gonna see it right now. So if I plug into Fast Ethernet 03, and this is like amber. You see that light? I don't know if you can see it. See, stay amber for I don't know how long. You see that?
Yes, sir.
So what I can do to expedite it, I can go to the Fast Ethernet 3, and I can say spanning tree, port fast,
Enable.
And notice what they say. Have effect is not if this is trunk, don't do it. Only you need to do it on non-trunking ports. Okay.
Gotcha.
So this is basically now if I test it, if I go back to that same port, which is F0/3, and you can disable it. See now is down. The minute I
Right.
put on, boom. Oh, it didn't take effect yet. Why not? Let me see.
Because we did it on port 2.
Port 2 or port 3?
Let's see.
Oh, let me see. Okay, spanning tree. Spanning tree. Okay, let me go back to make sure I'm on the right port. Interface FA0/3. Okay. Now, spanning tree, question mark. I need port fast. Okay. Enter. And also I need to put BPD. Oh, spanning tree. Spanning tree. BPDU guard enable. Okay. Exit. Exit one more time. Now, let's see over here what this is going to take. So I'm going to go to the configuration here. I want to disable it on 2 and on 3. So those two are down. So if we go, bring this one, click on 2, bring it up, and this one up.
Boom.
You see?
Boom. Yep.
Did
Got
we
it.
get it on 2 too? Usually this one takes long. Oh, maybe they learned it already. That's why. Yeah, they learned it already. But this goes faster because, and also we cannot pass any hello messages through this port, unless if this port is a trunk.
But if it's fast, I mean, it's not going to have a trunk.
Yeah, they give you a warning. If this is trunk, you cannot do it. If it's trunk, you cannot make it port fast or a PBDU. So you need to understand what's the main objective of the BPDU. The PBDU is messages, even if the port is blocked, but still can receive PBDUs. Like, are you there? Are you there? Are you there? Are you there? And also has some information, like an envelope. Inside that envelope of the BPDU, they have what? The bridge ID, BID. They have the priority. If this guy is going to send information to this, going to send them the priority and the MAC address. Priority and MAC address. Priority and MAC address. And the priority and MAC address is going to help the switch to elect who's going to be the root bridge. Question about this point. And that's the state. The operational details of each port. It goes to blocking, listening, learning, forwarding, and disabling. And that's the BBDU. So when it's a blocking, can we receive a PBDU? And the answer is yes. Even it's blocking. Blocking means you still receive that one. Listen, receive, and send. Now, notice here they say only. Receive only PDU, not other stuff. No data, no information, only PPDU. It's like the heartbeat. We need to receive it to see if the connected switch is still alive. It's not disconnected. So listening, receive and send, receive and send, receive and send. Learning, update table. So if any address on the address table change, we can update it. Notice over here, we don't forward any data, only we forward data on forwarding. See that? Disable, that means is some, like physically, like I did to the port, I shut it down. Then you cannot receive anything. That makes sense?
Yes, sir.
This is basically the different version of STP that we mentioned. And the way you want to change things to it, you go and change the mode. This is like we talked about it in the introduction. The first came in with the common RSTP, which is in the 80s, and somebody wrote the protocol, which is STA, spanning tree algorithm, in even the 80s. Okay. So it was too old. So Cisco said, well, instead, if I have a multiple VLANs, why I need to block this right here? So I can let it certain VLAN pass, and I can block certain VLANs on this side. So basically, we always can use that roads. I gave you an example for roads. We can block it for trucking, but still we can put small cars in that road. And the same thing, the link, the road that for trucks, we can allow the trucks, but we disable it for cars and so on. So over here, basically, this slide talks about a different version. And you can change the version you want to use. And it's good to have all the switches to be on the same version. Now, Cisco switch running iOS 15.0 or later run PVST Plus by default. This version incorporates many of the specification of IEEE 82 D, which is 2014. But the older version, which is the STP, like the regular STP, you can change it to rapid STP, which is the industry standard. Now Cisco, they enhanced the rapid STP by rapid what? PVST. Okay. So also depends on the OS, whatever OS you're using. Now, of course, if you have an older version, it's not gonna work. Now, what happened if you have two switches with different version? You revert back to the old one. You revert to the old one. And this is the rapid STP, which is, you need to pay attention to the protocol, the standard IEEE 802.1W. So the original STP was 802.1D, okay? So the rapid one is 802.1W. Now, rapid PVST, after the industry changed from STP, from this standard, from 802.1D, the industry changed, or the IEEE, to this standard. And Cisco says, okay, I'm not going to change too. I'm going to change from PVST plus to rapid PVST. You follow? And that's what happened. They change here. Rapid PVST is the Cisco implementation of rapid STP on per VLAN basis with rapid PVST plus an independent instance of RST runs for each VLAN. Follow? So always I can forward something on that link. I can block some VLANs, but I can forward other VLANs. Which is, I guess you can do it without PFSD. You can do it like what? When you say VLAN on the trunk port, you can say allow certain VLAN to path. So RSTP port state, which is the rapid, you have disabled, blocking, listening, learning, and forwarding. That's the STP. On the RSTP, this is all discarding right here. So learning and forwarding. So if you're using Cisco switches, basically you use what? You're gonna use the rapid PVST plus per VLAN, which is right here. Well, this is the industry standard. And basically any endpoints, they call it point to point. It's connected to the to other devices, to other switches, basically. So what happened here? The alternate port has path to the root bridge, which is this. Notice like, for example, I have designated, so that means this is root bridge. I got over here, this is the root port, this is the root port. Now it's blocked over here. Now you have two root port, you have a switch S3, and you have a hub right here. So what do they say? So the backup port is the backup port. The backup port is a backup to a shared medium such as a hub. Backup port is less common because hubs are now considered legacy. So if you have a hub here and you have a link here and link here, then one of them is going to be blocked. We call it backup port. But I hope nobody will have hubs anymore in the network because it's going to cause harm more than good. Okay, any question at this point?
No, sir.
Actually, we over time, so I'm gonna stop right here. And if you have a question, just send me an email or concern. And we can do more exercise tomorrow on this topic. All righty?
Okay. Yes, sir.
All right, so we're gonna stop here, end the recording, stop sharing here. I'll see you tomorrow.
Yes, sir.